lesson, lesson 137. We'll be looking at Introduction to Percents. All right, we're on pages 247 for exercises 1 through 3 all, and then we'll get into page 248, problem solving strategies for today. All right, so let's go ahead and look some facts here. So fractions and percents. Now, one thing to know is what fraction of a dollar is 1 dime? So here we have a dime. We need to ask ourselves, well, how many dimes make up a dollar? And if we know our money correctly, it'll be 10, right? So 10. So 1 out of 10, or 1/10. So that would be a fraction. Now, when we look at this, one fraction, we know something about percents is they're based off of 100. So our denominator is always going to be 100 with the percent. So if we were to raise our 10 to 100, we would multiply it by 10 times, and therefore the numerator would be our percentage, which would be 10%. Okay, so when we read this number, we need to make sure that we read the percent sign correctly. So this symbol is used to show a percent, and it is read percent. Okay, percent. Now, if we can break that down here, again, how many cents are in a dollar? Well, we know there's 100 cents per dollar. And look at the last part of percent. Okay, we have cent and cent. So it's per cent. So cent meaning 1/100th. All right, a centimeter is 1/100th of a meter. And so we got to make sure that we understand those kind of things when we read our words, okay? So what fraction of a dollar dime is? It's 1/10, and we get 10%. All right. So make sure we kind of base our percents off of this fact. Okay. Now, some fraction facts. So a fraction expresses a part of a whole, and 1/2 of the rectangle is blue. So we can see that here, and this half right here is blue, and the other half is a purplish. A fraction expresses a part of a whole as well. So we have 4 squares here, and 1/2 of the squares are blue. We can see 2 out of 4, so we have 2/4, and we can reduce that to 1/2, and that would be how we get this answer. So half of the squares are blue. Now a percent, okay, a percent is another way to express a part of a whole. Percent means per 100. Like I said, that per cent. And a whole is 100%. And that percent sign again is read percent. So here, just like we had 1/2 of the rectangle was going to be blue, now we have 50% of the rectangle is blue. So 1/2 is going to be equal to 50%. Same with our squares, okay? 50% of the squares are blue. Why? Because half of them are blue, right? 50%. And so we have to make sure we correlate these. All right. So a fraction expresses a part of a whole, and here we have a half of 100% is 50%, or 50% over 100% equals 1/2. They reduce. And so if we cancel these zeros, we have 5/10. 5/10 reduces by 5, and we're going to get 1/2. All right, so 1/2 is 50%. All right, now we're going to learn these common equivalent fractions and percents. So a half equals a 50%. Okay, 1/4 equals 25%. 1/4 is like a quarter. Okay, a quarter of a dollar is 25 cents. 25%. So 1/4 equals 25%. If you have 3/4, you have 75 cents. So 3/4 equals 75%. We've already done 1/10 equals 10%. 3/10 equals 30%. Any number over 10 is going to be that percent. So that's something easy to remember. So if you have 7 over 10 right here, you have 70%. If you have 4 over 10, you have 40%. Okay, So that's just something to take in mind. Anything over 10, any number over 10 is going to be the percentage. All right, so we just did this one. 9 over 10 is 90%. Now, 1/5 is 20%. So that would basically also be 2/10. And then 2/5, which is also 4/10, okay, is 40%. And then 3/5, which is also 6/10, is 60%. And then 4/5, which is 8/10, equals 80%. Okay, so these are common equivalent fractions. Memorize these, write them down, or just lock them away in your memory, and so that you can know that these are common ones. Okay. Now we're going to be looking at class practice, and you're going to have a square kind of like this. It's not like this because I didn't want to do the same one, but you're going to write a fraction, the percent of the blue part of each figure. Okay, so that's what we're looking at here, and we have a blue. We have 8 slivers of this square, and 4 of them are blue. So that becomes our numerator. 4 becomes our numerator. The whole is our denominator. There are 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. So the 8 becomes our total. And then how many are blue? 1, 2, 3, 4. That becomes our numerator. And then we can reduce that to 1/2. Okay, so half of these triangles in this square are blue, and we said a half is going to be 50%. Okay, so and we just looked at that before. If you look at the learn of these rectangle up at the top in that yellow box, you'll find that. All right, now write the fraction and percent for the blue part of the group. So we have 5 pencils total. So you have 1, 2, sorry, it's about 2, 3, 4, 5, and we have 3 of them are blue. So the 5 becomes our denominator, the 3 becomes our numerator, and we said 3/5 is equal to 60%. Okay, so 3/5 equal to 60%. So that's, I really didn't like that 6, so let's fix that. So we have 60%. All right. Now some problem solving strategies. Before we get into that, make sure you complete exercises 1, 2, and 3. All right. And then on section 3, answer the questions about the spinner. All right. You have a possibility of 10. The spinner has a possibility of landing on 10. And I told you, anything over 10 is equal to that percent. The numerator is equal to the percent. And so make sure you keep that in mind. All right. Now, we have educated trial and error. So 172 is a 3-digit number, and 170, the number n is the number, is a 3-digit number where the last digit is unknown. If 170 something is a 3-digit number that is divisible by 6, what is the value of n, the number? What we're trying to find that number. Okay, and look at the rule here. So a number is divisible by 6 if it is even and is divisible by 3. Okay, so with 3, we can add up the digits, and if they're divisible by 3, then it is going to be divisible by 3. If it is not divisible by 3, when you add the numbers up, then it cannot be 3. Now we have 2 stipulations. So it has to be divisible by 3 and even. So you have to take that in mind when we are doing this problem. So we have some steps here. Okay, think, how can I use the rule, which is the rule for divisibility for 3 and 6. Okay, 6 even number, and then also divisible by 3. All right, and trial and error to find the value of n, that last digit on 170 something. Okay, you could just write all the numbers out and figure out which one it is. That'd be easy, maybe, but we can use some process of elimination in a more quickly, and we could solve this easier. So that becomes our plan. We're going to break down the steps to solve. Okay, each step to solve. So based upon the rule, eliminate all odd digits. Odds gone. Okay, so that means 1, 3, 5, 7, and 9, right? You're going to use trial and error to find which even digit makes the 3-digit number divisible by 3 afterwards, and then keep trying the digits until you discover that one digit works. So we have 2, 4, 6, 8, and we have 0. Okay? We can end in, so we have to write all these digits out. So 170, 172, 174, 176, and 178. We add all these up, we're going to get 8. We add the digits on 1, 7, and 2, we get 10. 1, 7, and 4, we get 12. 1, 7, and 6, we get 14. 1, 7, and 8, we're going to get 15 plus 1 is 16. And all of these digits, except 1, is not divisible by 3 when we add them up. So 8 is not divisible by 3 because it's not 9. 10 as well. 3 can't go into 10, 14, or 16. So it does go into 12, so our number is going to be 174. That will be our number, right? And so we figured that out. And if you solve, you can see that. So let's go ahead and extend the problem. So for this 170 number to be divisible by 9, what is the value of n? And if we were to look back, all right, now this time we have to know the rule. So if it's divisible by 9, it has to be, the numbers have to add up to something that's divisible by 9. All right, now it can be odd or even sometimes, right? So 18 so we have to just kind of list these out. So then we'd have to have 1, 7, 0, 1, 7, 1, 1, 7, 2, 1, 7, 3, 1, 7, 4, 1, 7, 5, 1, 7, 6, 1, 7, 7, 1, 7, 8, 1, 7, 9. All right, so that's the only numbers we can have. We add this up, we add 170 up, you get 8, you get 9, and we already have a winner, and this is 171, so the n equals 1. This would not work because it's going to be 10, this is going to be 11, 12, 13, 14, 15, 16, 17, and 180 cannot work, right? Why should we stop finding after the 1? Because 180, we're already out of the 170s, so we can't use that. And then also, it's going to be 18, so that would work, but it's not going to work in that 170 range. All right, so that's problem-solving strategies. Let's look at finding the answer for number 1 on the problem-solving strategies. 59, so 590 something is a 3-digit number that is divisible by 6. So what is n? Again, divisible by 6, so has to be even, so we can cancel out 1, 2, or 1, 3, 5, 7, and 9. Those are all gone, right? And so we have to just keep the same rule as even and divisible by 3 and 6, right? So we can do 5, 9, 0, 5, 9, 2, 5, 9, 3, 5, 9, it's not 3. Can't be odd. 4, 5, 9, 6, 5, 9, 8, and that's it. So we add them up, we're going to get 14, right? We're going to get 16, right? And we're going to get 18, and 20, and 22. Now 6 we know goes into 18, or 3 goes into 18, and then also ends in an even number, so we have that n is going to be 4. Right? And so that's how we think, break down a plan, and then execute our plan. So go ahead and do section 2, or this problem solving strategies, numbers 2, 3, and 4. doing the exact same kind of steps here. All right, think, plan, and solve to execute. And our keyword for the day is percents. And we hope to see you in the next lesson.